everyone. My name is Enrico Levi, and I'm the founder and CEO of Florida Insect Control Group, doing business as INZECTO. I'm very glad to have you online for our webinar on the 2025 INZECTO products for mosquito control today. This afternoon, we have a rather international audience getting connected from a variety of countries and time zones. Thank you for taking the time to register and getting connected. Today's webinar will be held in English. Webinars in different languages will be offered in conjunction with some of our national distributors in the next few weeks. Information and communication about these events will be circulated soon. The first confirmed event will be hosted by INZECTO France. The webinar in French for the French audience is set for March the 12th at 5 p.m. So please join them to learn more about the INZECTO products in France. During today's presentation, we will describe the specification and how to use our mosquito control products. Please be aware that not every product mentioned in the slides is currently available in every country yet. Please refer to us and to your local distributor for regulatory information or product availability in your country. Please also be advised that the session will be recorded. Actually, it's already being recorded right now, and the video will be sent to all the participants, to those that register to the webinar, but will also soon be posted on our YouTube channels and other social media platforms. We will have a Q&A section at the end of the webinar. Please don't feel shy and feel free to ask questions. In order to do so, please use the Q&A section, and I will provide the answer at the end of the presentation. So going to the, starting with the presentation. Okay, the slides are not moving, hold on. Okay, I think that it's important to clarify how you develop innovative products. If you want to develop something new and effective, your entire project, your entire new development needs to be sustained by three fundamental pillars: biology, technology, and service. Biology means that you have to be very well aware of what is the life cycle of your insect target, how it feeds, how it reproduces, what attracts, what repels. But you also need to develop a technology that is effective at disrupting the life cycle of your target in a way that is efficient, long-lasting, safe for the people and for the other non-target animals. But also this needs to be capable of integrating well in the service that is provided to control the pest. So it needs to be affordable, it needs to be easy, it needs to be, it needs not to require too much maintenance and labor. So we started developing everything from the biology, and in order to do so, it's important to remind something that you probably all know very well, which is that the mosquito has four main stages of its metamorphosis, and three of them take place in the water. This information alone describes how fighting only the biting adults doesn't disrupt the life cycle. You might have won or win a battle, but you end up inevitably losing the war. Going deeper in the biology of the mosquitoes, you need to know that the mosquitoes want to lay their eggs where they see a food source for their larvae, in places that are shaded with high humidity and protected from the wind, where there are no predators, so no fish or frogs, containers with vertical sides, but where there is also a rough landing surface where they can have a grip and where they can lay their eggs. These containers come with a strong preference in terms of colors. Better if the sites already is with the existing larvae, and also the container needs to be close to where the mosquito live and bite. So mosquito will not fly long distance to lay their eggs Going even deeper into the biology of the reproduction of the mosquitoes, is important to know that mosquitoes seem to disappear during the winter, but they do not disappear. They have laid eggs that are capable of surviving the winter. Here in the glass container, you see that black ring. That is not dirt. Those are mosquito eggs. There are Aedes mosquito, Aedes aegypti mosquito eggs that are laid and ready to hatch as soon as the temperature and the water make it sustainable. So it's important to be aware that mosquitoes are present also during the winter. Based on this, the traditional system clearly present some challenges. The so-called ULV, ultralight, ultra low volume services that only kill flying adults provide short-term protection, need to be applied at sunset, and therefore they are not ideal for daytime biting mosquitoes like the Aedes aegypti or albopictus. They provide no larval control or prevention. Alternatively, the method that is usually used to treat the yards, we have barrier treatments. They provide usually a maximum of 3 weeks of protection, kill the resting adults, but also can be lethal for other useful insects, degrade in the sun and can be washed away by the rain, and cannot be applied on flowering plants or close to water due to limitation to protect water and pollinators. Also, this method does not provide larval control, so it's a method that you can use to win the battle, but you need something else to win the war. On top of that, there are the larvicides. The use of larvicides is not always that easy. Traditional larvicides usually provide a coverage of about maximum 3 weeks. They are often applied by the homeowners, but their application is usually very ineffective because you need an experienced eye to understand where water can accumulate and where mosquito can reproduce. What happens when you put these larvicides in the water is that you immediately make the water non-drinkable, and most of the larvicides float, so they can be easily washed away in case of rain and irrigation. To make things more complex, the systems of the pest control in general all over the world is experiencing new challenges, in the sense that more and more counties, countries, municipalities are passing laws and regulation that are aiming to protect pollinators, the waterways, food, plants, pets, livestock. So what we are facing also, due to the global warming and the extension of the period where mosquitoes live and bite, we are experiencing a growing threat, and we have fewer and fewer weapons to fight against the mosquito as a pest. So what did we do in order to develop a technology in this scenario? We engage the University of Florida, that has the #1 entomology department, and we were lucky enough to be funded at the beginning of our research by the Pentagon. The Pentagon has a program called the Deployed Warfighter Protection Program. I think the name says it all. That is that funded the fundamental research and gave also some guidelines to try to make products that were simple to use, because they needed to instruct the soldiers on how to apply this product, and the instruction needed to be necessarily simple. Our goal was to develop an innovative ovitrap, so a device, a place where female egg-laying mosquito would go to lay their eggs. And in order to do so, the first thing that we needed to do was to find, to design a container that would be more attractive than the competing containers that mosquito find traditionally in your yard. And this device needs to be able of killing both adults and larvae over a long period of time with minimal maintenance, interrupting the life cycle of the mosquito. These were the goal that we wanted to pursue. The first goal, the attractiveness, gave extremely high results. It was a success. You see this strange shape with these ribs. This device documented a reduction of the number of eggs laid in 4 competing containers after the introduction of one of our traps by 83%. This is an unprecedented data. There is nothing like this on the market, almost contradicting the biology of how mosquitoes develop their eggs, because they don't lay all their eggs in one basket. 83% is unprecedented data. Then, when it came to the killing, we created a product that attracts and kills based on shape, color, and scent. Shape, as I was telling you, is this pyramidal shape that with the ribs creates an environment with a very high humidity, and that remains the freshest place where mosquito can go during the hot summer. The colors that attract the mosquitoes are the black and the red. And the inner part of this container is covered by our microporous polymer that I will describe you more in detail, which is also texturized, so has the right roughness for the mosquitoes to land and lay eggs. We have also an element that is scent, in the sense that provides a scent to the water. The trap have a sachet with a leaf infusion, which basically has 2 meanings. One is that it helps offsetting potentially repelling smells that might come by tap water with chlorine or fluorine, but also is perceived by the female egg-laying mosquitoes like a food source for their larvae. They would not put their eggs into a container if the water is crystal clear, because they understand that their larvae would die after starvation. So these are the main characteristics. This is the real innovation in all this. So the traps have inside of their structure coating, and you see how whitish it is because it's embedded also with silica, embedded with adulticide and larvicide. So they provide a slow release of both adulticide and larvicide with extremely micro dosages of material. The water inside technically could remain drinkable by the low level of the insecticides, but still capable of being efficient with the mosquitoes. How do we do that? We attract the mosquito, again, shape, color, and scent. Female egg-laying mosquito lands on the internal surface to lay the eggs, dies at contact. Since we work with microdosage of insecticide, if some egg is laid, might develop into larvae, and then we kill them with both effect of the adulticide and the larvicide in the water. These are the data from the test, so you can see that the mortality at contact is roughly 98% over a period of 3 months, and 100% the pupal mortality for the larvae that eventually might develop. The application of the use of this trap also provides other advantages, in the sense that this kind of device helps avoiding the selection of insecticide-resistant mosquitoes. The WHO guidelines tell us that in order to do so, you need to work with different insecticide targeting different stages of the metamorphosis of the insect, like in this case. The trap is also safe for pollinators, which are not attracted by any of the element of the trap, scent, shape, or anything else. And the plastic is also recyclable. Here, you need to check with your national recycling program because there might be different protocols for the recycling of the product country by country, but in general, the plastic is fully recyclable and can be recycled. It's already up to 50% made of recycled plastic, but it will be also fully recycled. Where do you place these traps? You place them in shaded area, so not in the sun, 5 to 7 meters away. The coverage is between 100 and 150 square meters. You need to be aware that mosquito will not fly long distance. So on an average yard, you would have probably between 2 and 4 traps per place. You can place them close to people because they are safe. There is no contact of insecticide if someone touches the trap. We also suggest to either hang them up, which is possible, but also zip tie them to either a stick, like in this case, or the fence, or a bush, or a place where you can be safely kept. The other product that we developed, and it is complementary to the trap, is the product that we call the chip. The chip is nothing more than a ceramic tile, mosaic tile. The chip is coated with our polymer embedded only with larvicide. As you remember, we described earlier, the larvicides usually tend to float, and therefore the efficacy is gone if there is a rain or some irrigation. The chip, the ceramic chip, takes the polymer to the bottom of the container and slowly releases from the bottom. Very slow release, always working in the range between drinkability and efficacy. One of these chips approved for 100% pupal mortality for 90 days. So we have the evidence that the efficacy is also much longer, and it is effective up to 1,000 rinses. So water can be changed multiple times. We have also the evidence that targets only the larvae. So it's been proved not to affect fish or other animals living in the water. They can be placed in all these containers. It's important to know that the polymer releases the larvicide only when it's in contact with the water. So if the container is dry, it's almost like the efficacy stops and it restarts when the chip gets in contact with the water another time. So place the chip not only where you have the water, but where you know the water could accumulate. In this case, we have, again, 100% larva mortality for containers up to 20 liters. If you have containers that are slightly larger, you can probably work at putting more than one chip. Doesn't necessarily, it's not the solution if you have a problem with a lake, with a pond, or even a swimming pool. Very much in labs, and according to the WHO standards, the levels are below what the WHO would consider drinkable. We have a combination, the possibility of having a combination of the two. So combining the high attractiveness of the trap that eliminates 83% of the eggs in the other container, what we can do is add a chip to the container. We call this the larvae trap. It can be used to extend the trap's efficacy. The trap has a registration for 90 days, so you can put a chip after that. You might lose some of the adulticide efficacy, but you will still be very successful with the larvicide elements, or actually starting from scratch with a completely untreated trap, and you only put chips every 3 months. The benefit of this application is that is the lowest possible cost form of application, very easy to maintain, very safe, and there is a minimum impact or waste of plastic because the container is used multiple for many months. Definitely the entire one season, probably more. We decided to put here some data about a field test, an independent field test that was run in close to Turin in Piedmont. The location that was picked is probably the worst possible scenario you can find in terms of mosquito control. It's a cemetery. Everybody knows that cemeteries are the most difficult places to treat due to the quantity of little water container that they host. It was a test that went for 17 weeks, so more than 4 months, longer than the current and registered duration for our products. The area is an area that was not treated for over a decade because it hosts a feline colony, and so the municipality forbade any use of insecticide. It's a cemetery surrounded by a forest and agricultural fields with very low barriers from between separating the part inside and the outside, so mosquito can fly from different area. We treated the small section here, and we had 2 large controls area. This area has been documented as strongly infested by all form of variety of mosquitoes, mostly of the Culex and Aedes family. The test involved the deployment of 52 traps with an average density of 1 every 150 square meters, so at the highest board of the range that we suggest in terms of application. So really challenging the efficacy of the trap, considering the large amount of competing containers that were in the area. And also there were some manholes that we treated with the chips. Again, the deployment went over for 17 weeks, and it was only 1 deployment. So it was the same products that work for all of this period of time. Another element that I think was relevant was that only 25% of the traps needed a water refill during the hot Italian summer. This is due to the shape of the trap that minimizes evaporation. The tests were checked with the 3 BG Sentinel that you can see here. So in the most possible environment, these are the results. A 43% of reduction of Aedes and Culex mosquitoes. Considering the environment, we think this is a very significant result. This is a section, what to expect and what not to expect, that usually is a bit of a summary of the question that I usually receive. What to expect? Long-term mosquito reduction. So you will be able to notice a decrease of the biting mosquitoes over extended period of time. You will see visible results starting 10 to 15 days after the deployment of the product. You also will feel, you will experience a significant reduction of what you usually get in terms of a surge of the mosquito population after a summer storm, for instance. You might see presence of live larvae in the traps because the way the iriproxyfen works, which is a growth regulator, is a larvicide that works by stopping the passage from larval to pupae state, but they can reach the development of larval state. You can also see the complete absence of dead adults and larvae, because the adults don't necessarily die on the spot. They might fly out of the trap when they die, but also you might experience the lack of live larvae, because the adulticide in the water can kill the larvae at a very early stage. So if the populations of mosquito you have in your area is not particularly resistant to permethrin, you will probably not see any larvae in the water. What not to expect are immediate results, in the sense that it's a product that disrupts the life cycle. So only female egg-laying mosquito will go into the trap. So you need to make sure that they are at that level of their reproduction cycle. You might not see, don't expect to see a large number of dead adults of mosquito inside of the traps. They die, and those mortality rates that I showed earlier are very high, but they die because of the contact, not necessarily on the spot. So they might be able to fly outside of the trap and die in the range of a few meters around the trap. There is one thing that might be noted, and that might be important, especially if you are getting contracts with the municipality, so public contracts. So you need to be careful to understand what are the protocols for measuring the efficacy used by the municipality. So measure the reduction of biting adults versus the control area. If the full trap, the larvae trap, or the container with the chip with live larvae is brought to the lab, there will be zero emergence. If you start separating, like sometimes it can happen in some of the oldest protocols adopted by the municipality, the water and the larvae that you might find in the container, and bringing only that portion to the lab, therefore separating the polymer that releases the insecticide from water and larvae, you might get some emergence in the lab. So be aware of this element when you discuss with the municipalities about the protocols for testing the efficacy of your work. Service. This is a part that I think probably might be of bigger interest for all of you. How to integrate INZECTO into mosquito programs. We have described the results of about roughly 3 different programs. One, we call it INZECTO Essential, so how it integrates with the barrier treatments done 4 times a year, so not very frequently. Another one, we call it Mosquito Green, which is when it's a completely standalone treatment. And then the INZECTO add-on, when it treats only cover areas that are prohibited. What we suggest and what we recommend is to have, first of all, at least 3 deployments a year: March, June, and September. March for the prevention of the surge of mosquito at the beginning of the season, June the prime mosquito, and September at the end of the season, and for the so-called overwinter. I'll describe later what I mean by overwinter. These are some of the simulation that we did based on real data. So in red, you see what we should expect in terms of mosquito index with no control. In blue, what you would get if you, with only 4 residual barrier treatments. And in green, what you should expect with the integration of the residual of the barrier treatments with the INZECTO product. So a drastic reduction and no peak throughout the season. Relatively similar data if you have the INZECTO green, you are still capable of keeping the mosquito population down all the time. The so-called add-on is for areas where it is protected. And so you can put it in your yards when you have flowering plants, ponds, food plants, fruit trees, and things like this. I mentioned earlier a concept that I think it's innovative and probably original only to the INZECTO mosquito products, which is the overwinter. What happens when the PCO ends the treatments and the services, let's say at the end of October? What happens if you have a warm November and mosquitoes are still active in November? Two things happen. One is that the clients that paid for the previous season for the service are annoyed. They paid for a service and now they get bit in their yard. The second one is relevant from the entomology, from the life cycle that I described earlier. Those mosquitoes that are active in November are going to be the mosquitoes that will lay the eggs that will survive the winter. And therefore, they are laying the eggs that will represent the first generation for next year. So what we suggest is to deploy the INZECTO mosquito traps at the end of the service period. This application has two meanings. One entomological, the second one commercial. The entomology says that these traps will become a magnet for female egg-laying mosquito. They will be filled with the eggs. They might not necessarily develop right away if the weather conditions are not ideal for them to hatch, but they definitely will be full with eggs that otherwise would be laid in other containers, and there would be the eggs that would survive the winter and hatch in the spring. So therefore, when you will get rid of these traps in March or April, you will eliminate the thousands of eggs that otherwise would grow to be biting adults. The second is commercial. In our industry, pest control companies always struggle to have year-round contract, and every year there is a race to have a renewed contract, leaving something behind that reminds the client that something is done to control mosquitoes, even if the PCO is not providing a service there, but also reminding that the mosquitoes are an issue, provides a phenomenal excuse to engage with your clients early in the spring and renew the contract. How you promote INZECTO in your service? This is the result of experience with many clients. So these are just suggestions of how each pest control company can integrate our product in their protocols and in their brochures, I would say. So as a complement to traditional treatments, in order to get better protection and better service, to reduce the callbacks and potentially even the number of services, and also provide a visible sense of presence and service to your client. As a new eco-friendly service, and so to be offered to clients that are particularly sensitive to the environment, to pollinators, pets, and human health, but also in a situation where traditional services are not possible. You also can present it as the most cost-effective solution, where you have long duration, high efficacy, and extremely low maintenance. Basically, maintenance is just checking whether there is water, so you can provide an affordable service, an entry-level service for clients that otherwise would not be able to afford the most expensive services. And we have seen clients that also use that almost as a marketing leave behind. So they show really the client that the service is provided also when they don't see the PCOs in the yard. And I was suggesting earlier when I was talking about the overwinter program to facilitate year-round contracts and overwinter services. So this, a little bit in short, is that simple, one step, one part, stable in all temperatures, works throughout the season. Technicians love it because the PPE that is necessary to use is just minimal. Actually, according to the country, we have a maximum, the request is the use of gloves. You have a high customer satisfaction. You will have, we say, happy pollinators. I mean, there will be no problem in this respect, and it can be presented as an eco-friendly solution. Here is our contacts for additional information involving the regulatory situation, the distributors, the labels, and all the other